This is another episode of Christopher Reads the Help Files. In this one, it's Getting Started, Surfaces Workflow. Refer to this section for high-level descriptions of tasks you can perform when working with surfaces in Civil 3D. And I'm just going to go straight into the topics instead of reading all of them. Workflow, to prepare for surface creation. Before adding surface data to a drawing, ensure that the styles and settings are set up. Consider creating drawing templates that contain standard styles and settings. It helps you work more efficiently and ensure that your final drawings conform to your office standards. Create a new drawing. Open an existing drawing or create a new one. Select the default surface settings. Specify the default behavior for surface-related commands. Create the surface styles. Use the Toolspace Settings tab to create a surface style. Create the surface label styles. Use the Toolspace Settings tab to manage surface label styles. Create the surface table styles. Use the Toolspace Settings tab to manage surface table styles. Save the drawing as a template. Save the drawing as a template enables you to leverage the styles and settings. So here we have create, but then they switch to manage. I mean, it really should be consistent. I would expect it to say create instead of manage, or manage needs to be replace the create on the left-hand side for those items. Workflow, to create a surface and add surface data. When you create a surface, the surface may be empty and therefore is not visible in the drawing. However, the surface name is displayed in the prospector tree, so you can perform other options such as adding data. Create a new surface or import a surface. Create an Autodesk Civil 3D tin surface from a point file. Define a boundary for the surface, and then force the surface triangulation along linear strings. Watch video, create a surface. I don't know. For the linear strings, you have to import data first. So I don't quite get that. And then the boundary, after the data is added, unless the boundary is used to restrict data. I know there's a different terminology that Civil 3D uses to restrict, but I'm just going to go ahead and use that value or that wording. Review the surface editing options. Expand the surface item in the prospector tree to display its data. Add edit surface data. Edit operations are added to a surface definition. Watch video. Add data to a surface. Review the surface definition. A surface definition is a collection of a surface's build, data, and edit properties. Manage the surface. View and change the surface and its data. I'm not quite sure what manage the surface means. So it's really all of the editing for it. So I'm just going to go back. So I guess you're managing it. To analyze surface information, you can create analysis of surface data and view surface information and statistics. View the statistics for the surface. Autodesk Civil 3D provides extensive statistics based on the current state of the surface. Create an analysis of the surface. You can analyze depressions, elevations, contours, slopes, and watersheds. Calculate volumes. Query composite and bounded volume differences between surfaces. There's got to be two of them. Analyze water drop paths. Trace the path that water takes across a surface. Watch video. Create water drop paths. Check for contour problems. Identify problems with contours that are drawn according to surface styles. Contour settings? So this should be from the data, not the style. So it's data added to the surface, not the style, right? Because you add the data and then you're going to look for contour problems. And then when you fix the contour problems, you're most likely going to go and fix the data and not fix the style, because the style doesn't really affect any problems with the contours. Workflow to analyze surface volumes using the volumes dashboard. Use the volumes dashboard to analyze volume surfaces and bounded areas within those surfaces. Open the volumes dashboard and create a volume surface. Select a base and comparison surface to represent the area you want to analyze. Assign a style to the volume surface that displays the cut and fill elevations. You can assign a style to the volume surface when you are creating it, or you can use the style column in the volumes dashboard. A style such as cut fill banding 1, interval 2D, which is included in the Autodesk Civil 3D drawing templates, is a style that is used to show elevation analysis banding above and below datum. On the Analysis tab of the Surface Style dialog box, verify that the range interval with datum is selected. On the Display tab, verify that the elevations are visible. Perform an elevation analysis of the volume surface. Right-click on the volume surface in the Volumes dashboard and click Properties. Select the range interval with datum option when creating the ranges. The elevation analysis is displayed in the drawing using the style you selected above. Add a bounded area and examine the volume results. The bounded area is added beneath the volume surface in the Volumes dashboard. Edit the surface to optimize the volume balance. If volume results in the Volumes dashboard do not update automatically, you can update the results by pressing the Recompute Volumes option. Generate a volume report. The selected volume surfaces and bounded areas are included in the report. Insert a summary of the volumes results into the drawing. The selected volume surfaces and bounded areas are included in the table. I guess that all sounds okay. To analyze stage storage volumes, this report is like, sucks, right? It doesn't calculate it if you have a complex basin. What it does is that it does it based on elevations of it, and it assumes it's a simple basin. So if you have complex contours and big basins and small basins, it won't calculate the information correctly, and it'll give you garbage. Autodesk doesn't seem to want to fix this, but you can find tools that do it correctly within Steltman tools. And there might be other third-party products out there, but I know that Steltman tools work because I wrote it or helped write it and correct any issues that it used to have. And so now it does it correctly, much better than Autodesk's version of it. And it does it on complex ponds in basins. Use the stage storage command to analyze the stage storage volumes of basins. Determine the boundaries for a basin to be analyzed. Before you analyze a basin, use either surface objects or polylines to create the basin boundaries. Edit display settings for contours. You can calculate basin volumes. You must ensure the contours are displayed in the surface style. Like, I don't get why you need to do that step and not just have the stage storage allow you to just type in the elevations. It's pretty lazy for Autodesk to expect you to set the styles and then extract the contours from the surface and then do the areas based on that, because it doesn't give you correct numbers on a complex surface. Set up a stage storage volume report. In the stage storage volume analysis dialog box, enter the administrative and calculation information for the stage storage volume analysis. Define the basin. Define the basin by selecting surface objects or polylines in the drawing, or by manually entering surface object parameters for the basin. Save and display the stage storage volume table. Save the stage storage volume table and display it in the drawing. Save and display the stage storage volume report. When you save the stage storage volume report, the report opens in your default text file viewer. I would strongly suggest not using this version unless your basin is really simple and basic and just goes from the lowest elevation to the top. And even then, it has some problems in some situations. If you have something more complex, I would just double check this work because it gives you garbage if you don't really understand what Civil 3D is doing because it's doing it wrong for complex basins. So that's just my word of caution. If you're going to use this tool, it really does suck. And so this concludes Christopher Reads the Help file for the surfaces workflow.